Welcome back, my dear students. Get ready because today we are jumping right into your ultimate Chapter 7 masterclass on weather, climate, and planetary motion. I am your science teacher, and I'm so excited to teach you this. We're going to break down every single secret of this chapter so you understand it perfectly, remember it easily, and most importantly, score full marks on your exam. So sit up straight, give me your full attention, and let's get started. Let's start with a really simple question, just to warm up those science brains of yours. Look away from the screen for just a second. What's it like outside your window right now? Is it hot, maybe a bit cold, rainy, or is the sun just beating down? Well, those atmospheric changes happening right outside, right at this very second, that is exactly what we are going to scientifically decode today. Okay, let's look at this real weather report for Bangalore straight from your textbook. It's for a Thursday morning at 11 a.m. Look closely at the specific metrics they've recorded here. It's mostly cloudy, the temperature is 26 degrees Celsius, precipitation is just 2%, humidity is sitting at 79%, and the wind is blowing at 34 kilometers per hour. Now, this isn't just random data, right? These are the exact, precise metrics that scientists, or meteorologists, monitor every single day to figure out what the weather's going to do tomorrow. So here is our game plan for today's explainer. We're going to decode the weather report, battle it out between weather versus climate, zoom out to space for Earth's climate factors, check out the Earth's tilt, map out the solstices and equinoxes, and then boom, we'll finish up with a quick Let's Remember exam quiz to test your memory. All right, jumping right into Section 1, decoding the weather report. Now listen closely to this because this definition is absolutely vital for your exams. The state of atmospheric conditions at a given place and time, that is officially called the weather of the place. And these specific factors, temperature, humidity, rainfall, snow, cloud cover, wind, we call these weather elements. The biggest takeaway here? Weather can change in a flash. You know how it is? You wake up, it's beautifully bright and sunny, and by afternoon, bam, you're caught in a massive downpour. That rapid change, that's weather in action. Okay, grab your pens because these three measuring instruments are literally guaranteed to be on your exam paper. Meteorologists use special tools for these weather elements. To grab the highest and lowest temperatures of the day, they use a maximum-minimum thermometer. Simple, right? Now, to measure the exact amount of rainfall, they use an instrument called a rain gauge. And to figure out the relative humidity of the air, they use what's called a hygrometer. Lock those three terms into your brain right now. Maximum-minimum thermometer, rain gauge, and hygrometer. Moving smoothly on to Section 2. Weather versus climate. This is a classic exam topic where students always get confused. Let's clear it up once and for all. Weather, like we just saw, is short-term. It's the daily, sometimes hourly changes. But climate is the characteristic pattern of those weather elements observed over a very, very long period of time. It's the big picture. So lock this visual into your memory. Weather tells us what's happening today, but climate tells us what it's usually like in the place where we live. And this brilliantly shows exactly what I mean. Just look at our beautiful country, India. In June, we know it's going to be mild in Bengaluru, super humid in Kolkata, hot and completely dry in Rajasthan, bitterly cold up in Ladakh, and pouring rain down in Kerala. That characteristic pattern, that is their climate. And it's so incredibly important because it dictates our whole way of living, what clothes we buy to stay comfortable, what crops our hardworking farmers can successfully grow, and even the delicious food we eat. All right, let's zoom way out into space for Section 3, Earth's climate factors. Just look at this staggering number, 15 million degrees Celsius. The sun is our ultimate source of energy, and it creates this massive heat through continuous nuclear reactions. We feel the gentle warmth here on Earth, but its core, it reaches an unbelievable 15 million degrees, just blasting energy out in all directions. And to put that power into perspective, look at the sheer difference in scale here. The sun's diameter is about 1.39 million kilometers. Our Earth, just around 12,700 kilometers. It's like comparing a grain of sand to a massive boulder. But you know what? Our distance from this giant furnace is absolutely perfect. We're about 149.6 million kilometers away. If we were just a tiny bit closer, we'd burn up. A tiny bit farther away, and our planet would freeze solid. This just right distance is a massive factor in keeping our climate perfectly suited for life to thrive. But my dear students, watch out. Examiners absolutely love a trick question. Is distance from the sun the only thing that determines how hot a planet gets? No way. Look at Venus. Venus is actually farther away from the sun than Mercury is. But guess what? Venus is way hotter than Mercury. Why? Because Venus is completely wrapped in a super thick atmosphere of carbon dioxide that traps all that heat like a heavy blanket. Never, ever forget that exception. Okay, let's bring it back home for section 4, the Earth's tilt. Before we talk about the tilt, we really need to clearly define the elliptic plane. As the Earth revolves around the Sun, the path it takes is called its orbit. Now just imagine a giant, flat surface that this entire orbit sits on. That imaginary flat surface, that is the elliptic plane. Now here is the secret to literally everything, from our changing seasons to our daylight hours. As Earth travels on that elliptic plane, it's spinning like a top on its own axis. But that axis isn't perfectly straight up and down. Nope, it leans. Please write this exact number down right now. The angle of inclination of the Earth's axis relative to the perpendicular of the elliptic plane is exactly 23.5 degrees. So what does this actually mean for us? Because of this 23.5 degree tilt and where we are in our orbit, the specific area of the Earth lit up by the Sun is constantly varying. This means the length of our day, the time between sunrise and sunset, doesn't stay the same throughout the year. If you look at places near the equator, their days are pretty steady. But if you travel up near the poles, you'll see massive, wild variations in when the sun rises and sets. Which brings us perfectly to section 5, solstices and equinoxes. Let's map out the Earth's journey over a full year. Around March 21st, the sun hits the northern and southern hemispheres equally. We call this the spring equinox for the north. Fast forward to June 21st or 22nd, the north is tilted right toward the sun. Bam! Summer solstice, the longest day of the entire year in the northern hemisphere. Then around September 23rd brings us the autumn equinox. And finally, on December 21st or 22nd, the north leans away, giving us the winter solstice, the absolute shortest day of the year in the north. And here is the most extreme, mind-blowing result of that 23.5 degree tilt. The north and south poles only get one single sunrise and one single sunset for the entire year. Think about that. At the North Pole, the sun rises around March 21st and literally does not set until September 21st. The South Pole is the exact opposite. It is basically 6 months of pure, continuous daylight, followed by 6 solid months of darkness. All right, close those textbooks. It is time for Section 6, our Let's Remember exam quiz. Let's see what's stuck in those brains. I've got 3 fill-in-the-blank questions here, straight from your syllabus. Number 1, a hygrometer measures blank. Number 2, the Earth's tilt is about blank. And number 3, climate blank has, or has not, remained the same through the ages. I'm going to pause for just a few seconds. Try your absolute hardest to shout out the answers before I reveal them. Ready? Okay, let's check how you did. Number 1, a hygrometer measures the relative humidity of the air. Number 2, the Earth's tilt is exactly 23.5 degrees. And number 3, the climate has not remained the same. Just think back to the ice ages when massive parts of the Earth were buried entirely in ice. If you got all 3 of those right, give yourself a huge pat on the back. You were doing wonderfully, and you're well on your way to an A+. We really covered so much ground today, didn't we? From local rain gauges to the nuclear core of the sun and the mechanics of our spinning, tilted planet, the study of climate is just such an exciting and challenging field of science. I want you to walk away remembering that our entire way of life, our crops, our clothes, our seasons, it all hinges on a tiny 23.5 degree angle of inclination. Which leaves us with a pretty fascinating question. If this tiny tilt completely dictates human survival, what do you think would happen to our world if that angle shifted even by a single degree? Something to think about next time you're watching a beautiful sunset. My dear students, please come back and listen to this explainer again and again anytime you need to perfectly revise Chapter 7. I am always here to help you learn. Keep studying hard, stay curious, and I'll see you in our next masterclass. All right, everybody, settle down, notebooks out, sit up straight, and pay close attention. I am absolutely thrilled to have you all here today because you've just stepped into your ultimate masterclass for your 7th standard science exam. Today, we're decoding one of the absolute most fascinating topics in your entire syllabus, the dynamics of climate and animal adaptations. We're going to break down exactly how our planet's environment works, and, more importantly, how the incredible animals that share this Earth manage to survive and thrive in the most extreme conditions you can possibly imagine. This explainer is your golden ticket to acing that exam, so let's get started with some high energy. Okay, quick look at today's lesson plan. We're covering 6 key modules. First, the factors deciding our climate. Second, weather versus climate. Third, an introduction to animal adaptations. Fourth, surviving the hot deserts. Fifth, thriving in the tropics. And finally, beating the extreme cold. Clear expectations, clear focus. Let's conquer this syllabus. Okay, let's dive right into Section 1, Factors Deciding Our Climate, the rules of the game. Before we can understand how animals survive, we absolutely must understand the rules of the game they're playing. You see, the climate of any place on Earth doesn't just happen by magic. It depends on several strict geographical factors. Let's unpack the first major one, distance from the equator, or latitude. Listen carefully, because this is a classic exam question. Places closer to the equator are warmer than places closer to the poles. Why? Well, because the sun's rays fall directly on the equator, but they hit the poles at a really sharp angle. This is exactly why a country like India is, on average, so much warmer than a place like Greenland. Direct heat versus angled, dispersed heat. Very simple, very important. Now, what about altitude? The definition you need to memorize is that altitude is the height of a place above sea level. The golden rule here is the higher a place is, the cooler it is. Think about it. Why do we all beg our parents to take us to hill stations during the scorching summer holidays? It's because those hill stations sit at a much higher altitude than the plains, which gives them a wonderfully cooler climate. Next up, we can't forget the sea and the mountains. The sea actually has a fantastic moderating influence on climate. If you live in coastal areas like Mumbai, Chennai, or Kolkata, your climate is neither extremely hot nor extremely cold. But if you move inland, far away from that sea breeze, you get hit with extreme climates, scorching hot summers and freezing cold winters. Also, keep in mind the power of mountains. The mighty Himalayas directly affect the climate of North India because mountains can actually change or even completely stop winds, and that heavily influences rainfall. Moving smoothly to Section 2, Weather versus Climate, Temperature and Humidity. So that covers the grand long-term rules of climate. But what about the day-to-day weather? While climate is the long-term pattern, daily weather is driven by temperature and humidity. And this brilliantly illustrates a massive modern problem we face. Just think about the temperature difference between our bustling cities and our villages. During the day, the sun's rays heat up the earth, sure, but temperatures can actually be many degrees higher in urban areas compared to rural areas. Why is that? Because our cities trap heat. We've got higher pollution, a dense population crammed into houses, concrete literally everywhere, and far fewer trees. We're essentially building giant heat traps. Now think about some weather data from a single day in April. We have New Delhi with 25% humidity, Chennai sitting at a sticky 69%, and Jaipur down at a bone-dry 8%. Just picture that stark contrast. What conclusions can we draw from this? Well, it tells us that even on the exact same day, in the exact same country, weather conditions can be wildly different. And this leads us to our next big question: how does life actually survive in such varying extremes? Which brings us to Section 3, Introduction to Animal Adaptations. How the players survive. Despite harsh, sometimes terrifying climatic conditions, we see biological players, meaning plants and animals, living everywhere by modifying themselves. Students, grab your mental highlighters, make a massive note of this definition because it is the most important concept of the entire chapter. Adaptations are changes in the structure or behavior of an organism that allow it to survive in a particular habitat. Whether it's a physical change in their body or a change in how they act, this is the ultimate key to survival on Earth. One really incredible behavioral adaptation is migration. This is the mass movement of birds or animals from one place to another. Think of it as nature's way of taking a necessary, urgent vacation when things get just a bit too tough. They migrate to avoid seasonal changes, escape unfavorable climates, find food, or breed. And the absolute best part, they always fly or walk back to their native home once those favorable conditions return. All right, Section 4, Surviving the Hot Deserts, Beating the Heat. Let's travel to the hottest, driest places on Earth, the deserts. Out here, water is the ultimate luxury, so animals extract it from fleshy plants or even the bodily fluids of their prey. I want to pause right here and ask you a question, a true Socratic question for my bright students. We all know the camel is the ship of the desert, but scientifically speaking, based on adaptations, how exactly does a camel survive the blowing sand and the blistering heat without drinking water for a week or more? Think about it for a second. What are its secrets? Well, what's really fascinating about this VIP checklist of survival traits is that the camel is basically an adaptation machine. It has long eyelashes, ear hair, and nostrils that physically close up to keep out blowing sand. It has thick eyebrows, acting as built-in sunshades, wide feet so it doesn't sink into the soft dunes, thick lips to safely chew prickly desert plants, and that famous hump? It's not a water tank. It is a brilliant survival reservoir of fatty tissue that lets it go months without food. Oh, and a quick note on desert reptiles and birds. They excrete their metabolic waste as solid white uric acid to waste almost zero water. And get this, 34 degrees to 41.7 degrees Celsius. This is a shock value adaptation right here. Unlike us humans, a camel can withstand wild fluctuations in its internal body temperature throughout the day. Why is this a superpower? Because by letting its internal temperature rise alongside the scorching desert heat, the camel completely avoids sweating. And no sweating means it conserves its incredibly precious water. Then we have the absolutely fascinating story of the kangaroo rat. This tiny genius builds what is essentially an underground moisture recycling AC room. They live in sealed burrows to block out the harsh midday heat. They literally recycle the moisture from their own breathing inside the burrow. They only come out in the cooler mornings and evenings. And here's the real kicker. They never drink water. Ever. They get 100% of their water requirements simply by digesting dry seeds. Just amazing.
Let's switch gears. Section 5. Thriving in the tropics. Heat, humidity, and intense competition. Let's leave the dry desert and enter the hot, incredibly humid tropics. Animals here can't just conserve water. They need to cool down constantly through evaporation, using active sweating, heavy panting, or even licking themselves. Let's see how this builds into an incredible biological process. Take the African elephant, for example. Animals in the tropics often have large ears, but the elephant takes it to a whole new level. These ears are literally built-in fans. Step 1. The elephant flaps its massive ears. Step 2. This action blows air that specifically cools the blood rushing through the ear's blood vessels. Step 3. That freshly cooled blood circulates back into the body, lowering the elephant's overall temperature. Pure biological engineering. But heat isn't the only problem in the tropics, right? There is intense competition for food and a whole lot of predators. Enter camouflage. This is being shaped or colored to perfectly match your surroundings, making you practically invisible. Leaf insects and stick insects are absolute masters of this. Meanwhile, other animals, like monkeys, adapt by simply changing their address. They live way high up in the tree canopy. This brilliant move keeps them safe from ground predators and massively reduces their competition for food. Finally, zip up your jacket, students. Section 6. Beating the extreme cold, surviving the freeze. We are traveling to the freezing poles. In extremely cold climates, survival is all about keeping the heat in. Some aquatic creatures adapt to the stable temperature of the freezing water itself, while others use heavy muscular activity to keep warm. But the ultimate champions of the freeze are animals like polar bears, seals, whales, and walruses. They survive the worst cold on Earth, using a thick, heavy layer of fat deposited directly under their skin, called blubber. It's basically nature's ultimate thermal wear. Polar bears also sport thick, white, waterproof fur. This acts as a secondary insulator and provides perfect snow camouflage for hunting on both land and water. So the crucial point is, what happens when winter is at its absolute worst and there is zero food around? Well, they use hibernation. This means remaining utterly inactive or dormant. Female polar bears literally dig dens deep into the snow. While hibernating inside, they don't eat or drink. Instead, their body brilliantly converts that stored fat directly into energy to keep them alive. In fact, female polar bears even give birth to their cubs inside these dens while in this energy-saving dormant state.
Okay, students, it's time for a serious teacher moment in our green corner. We've talked all about adaptation today. But what happens if the climate changes way too fast for an animal to adapt? Well, just ask the dinosaurs. Some scientists believe dinosaurs went completely extinct simply because they could not adapt to a rapidly changing climate. This is the ultimate cautionary tale for all of us. We must work to keep our current climate stable, or countless other beautiful species might face the exact same fate. And that wraps up our lesson. I have a provocative question for you to ponder. Just like the amazing animals we studied today, will you be able to adapt your study habits, absorb this crucial information, and absolutely master your upcoming science exam? I know for a fact you can.
To guarantee your success, I strongly encourage you to return and listen to this explainer anytime, again and again. Repetition is the ultimate adaptation for a top student. Keep studying hard, stay curious, and I will see you all in the next masterclass.
Hello, my brilliant 7th standard students. Welcome to today's masterclass. I'm your teacher, and let me tell you, if you focus and pay close attention to this explainer today, you are absolutely going to crush your Chapter 7 exams. We're going to unlock all the secrets of weather elements and animal adaptations together. So grab your notebooks, get comfortable, and let's go get those top marks.
Here is exactly what we're conquering together today. Weather versus climate, the factors changing our climate, desert survival and adaptations, freezing cold polar adaptations, tropical climates and camouflage, and finally, measuring weather with math.
All right, let's jump straight into Section 1, Weather versus Climate.
Now, you might be wondering, what's the actual difference here? Well, when we talk about weather, we're talking about short-term changes. It's simply what's happening in the atmosphere at a specific place and time. Like, is it raining right now? Is it sunny this afternoon? But climate is the characteristic long-term pattern of those weather elements over a very long period. So the easiest way to remember it for your exam, weather is like your mood today, but climate is your overall personality. Lock those exact definitions into your memory right now.
Okay, time for some rapid-fire revision. You absolutely need to know your scientific instruments. To measure the temperature, we use a maximum-minimum thermometer. To figure out the exact amount of rainfall, we look at a rain gauge. And to measure relative humidity, which is basically how much moisture is floating around in the air, we use a hygrometer. 3 instruments, 3 guaranteed marks on your paper. Moving right along to Section 2, the factors that are actually changing our climate. Look at this number on your screen, 23.5. I want you to memorize this exact number. Why? Because our Earth doesn't sit perfectly straight up and down. It actually has an angle of inclination, a tilt, of exactly 23.5 degrees. And this specific tilt is the entire reason we even experience changing seasons. Without 23.5, our world would look completely different. So what actually shapes the climate of a place? Let's count them down together. First, our overall distance from the sun, which is about 149 million kilometers. Massive, right? Second, that 23.5 degree tilt we just talked about. Third is latitude. Remember, the sun's direct rays make the equator super hot, while those angled rays make the poles freezing cold. Fourth is altitude, meaning your height above sea level. Fifth is your distance from the sea, which has this huge moderating effect. And finally, the presence of mountains. Mountains are so incredibly massive, they can literally change or completely stop winds and rainfall. And you know, this brilliantly illustrates that fifth point. Think about how a coastal city like Mumbai, Chennai, or Kolkata actually feels. Because they're right next to the sea, they have moderate climates, never too hot, never too cold. But compare that to inland areas far away from the coast, like Delhi or Rajasthan. They experience totally extreme climates with scorching summers and freezing winters. An inland city like Jaipur is also going to have much lower humidity than a coastal city like Chennai. The sea truly makes all the difference.
Okay, Section 3. Let's talk about desert survival and adaptations.
So, the absolutely crucial point here is this exact definition. What is an adaptation? It's the changes in the structure or the behavior of a species that allow it to survive in a particular habitat. Listen carefully. It's not just about how an animal looks. It's about how its body functions and how it behaves to conquer its natural environment.
Pay very close attention, my brilliant students. This is a guaranteed long-answer exam question. The camel is the ultimate desert survivor. First, and please do not get this wrong, the hump acts as a reservoir of fatty tissue, not water. Actually, scratch that. Let me say it again. Not water. This fat provides energy for weeks. Second, they have incredibly thick lips to eat thorny desert plants. Third, long eyelashes, ear hair, and nostrils that can literally close shut to block out blowing sand. Fourth, wide feet so they don't sink. And fifth, they can tolerate body temperatures up to 41.7 degrees Celsius. This stops them from sweating, which saves precious water.
Let's apply what we just learned. Think about this for a second. Could a polar bear eat a cactus with thorns? The answer is absolutely not. No way. A polar bear is adapted for the freezing Arctic, not the scorching desert. Only an animal perfectly adapted to its habitat, like the camel with those tough, thick lips, can munch on prickly desert plants without hurting itself.
Now check out these two incredible desert survivors. The fennec fox has unusually long ears. Why? To dissipate heat rapidly right out of its body into the air. Then there's the kangaroo rat. This tiny genius doesn't even drink water. I mean, it literally gets all the moisture it needs just from digesting dry seeds. Nature is truly mind-blowing, isn't it?
Brrr. All right, moving on to Section 4, Freezing Cold Polar Adaptations. Let's completely unpack the polar bear survival kit. How on earth do they survive the Arctic? First, they have a thick layer of fat right under their skin called blubber, which traps their body heat. Second, their white fur is a brilliant double feature. It acts as a warm insulator and as the perfect camouflage to hide from their prey against the snow. Third, female polar bears dig dens and hibernate, basically staying completely dormant during the absolute worst parts of winter. And finally, their furry paws act exactly like snowshoes so they don't sink deep into the snow.
Now remember earlier when I said adaptation is about structure and behavior? Well, look at penguins. They survive the severe Antarctic cold by huddling together in large groups. Sharing body heat like that is a purely behavioral adaptation. The male penguins also huddle together tightly just to protect their precious eggs from the freezing, biting winds.
And sometimes the absolute best survival strategy is just to pack up and leave. Birds like the snow geese and the incredible Arctic terns avoid those harsh, unfavorable conditions by migrating. They fly thousands of kilometers to warmer regions to find food during the harsh winter, and they only return when the weather finally improves.
Let's warm up a bit in Section 5, Tropical Climates and Camouflage.
All right, here's a brilliant question to test your analytical brains. Why do African elephants have much larger ears than Asian elephants? Let's break this down. African elephants live in much hotter tropical climates, right? Well, they actually flap those massive ears to blow air across their skin, which cools their blood. That cooled blood then circulates and cools down their entire massive body. Their ears are quite literally built-in biological fans.
In these lush, tropical jungles, hiding is quite literally a matter of life and death. With camouflage, animals like leaf insects and stick insects are shaped and colored exactly like their surroundings. It makes them almost impossible to spot, keeping them completely safe from predators. But hey, predators use it too. An owl blending perfectly into tree bark can hunt its prey without ever being seen until it's far too late.
Finally, Section 6, Measuring Weather with Math.
We're bringing a little bit of your math syllabus into science today. When scientists track weather elements like temperature, they use data, and we represent that data visually using a bar graph. Right here, we're plotting the exact maximum temperature in degrees centigrade for a few days. Monday was 29 degrees, Tuesday peaked at 31, and Wednesday dropped to 27. Using maths like this lets us easily spot the exact climate patterns we talked about at the very beginning of the class.
And boom, just like that, we have completely conquered Chapter 7. You are all brilliant students, and I am so incredibly proud of the focus you've shown today. Now, to make absolutely sure every single detail is locked into your mind for exam day, I strongly encourage you to listen to this explainer again, hit pause, and practice those definitions. Before you go, I want to leave you with this final, provocative thought. If the Earth's axis was suddenly tilted at a full 90 degrees instead of 23.5, just how extreme do you think your next summer would be? Think about it. Keep learning, keep studying hard, and I will see you in the next explainer.